Welcome to screencast number 1 for Unit 5, Lesson 1. I'm on page 224, and we're going to talk about the Earth's days, years, and why the Earth has seasons. Alright, on page 224 it says, by the end of this lesson you should be able to relate Earth's days, years, and seasons to Earth's movement in space. Please notice on page 225 there are, they gave you 7 vocabulary terms, but I added some more, and I do expect you to define all of those vocabulary terms on the graph paper at the end of the lesson where it says notes. The ones they gave you: rotation, season, day, equinox, revolution, solstice, and year. Define those, but in addition to those, you need to define zodiac, terminator, Tropic of Cancer, Tropic of Capricorn, ecliptic, and axis. Now, some of those will be covered as we cover the lesson, but if they're not, what I have done is I have taken a regular old dictionary from my room, and I have marked and highlighted the definitions that you need. Okay, for instance, down here, there's one of them. Okay, so that'll help you out a little bit, but I do expect you to define those. Alright, let's get started. Alright, I'm now on page 226. What determines the length of a day? Each planet spins on its axis. Well, what is an axis? Well, the Earth's axis is the imaginary straight line that runs from the North Pole to the South Pole. There's not actually a big rod sticking out of both poles of the Earth, but we often draw one to represent the axis. Okay? So the spinning of a body such as a planet on its axis is called rotation. The time it takes for a planet to complete one full rotation on its axis is called a day. Okay? Alright, so down in the box where it says the time it takes for Earth to rotate once, it just so happens that Earth rotates in a counterclockwise motion around its axis if you are looking down at the Earth from above the North Pole. And this means that a location on the Earth's equator rotates from west to east. The sun will appear to rise in the east because of the way that the Earth is rotating. As the Earth rotates, only 1/2 of the Earth faces the sun at any given time. The half that's facing the sun is having daytime and is getting daylight from the sun, and the other half that's facing away from the sun is experiencing nighttime. And there is a boundary line between daytime and nighttime. Okay, so we always have half of the planet lit by the sun, but the boundary line between the half that's lit and the part that's unlit is called the terminator. Okay, the terminator is just simply the boundary line between daylight and darkness. Okay. So Earth's rotation, how long it takes to spin on its axis, is very helpful when we want to measure time. Okay, Earth completes one rotation on its axis in 24 hours, which is what we call one day. Okay. All right. So first thing I want to show you, here is our globe. Here's the North Pole. The South Pole obviously is down here. And what they're saying is that the Earth, if you're looking down on the Earth from the North Pole like we are, the Earth is going to rotate on its axis this way. Okay? So if you see this little shiny spot over here, let me tilt it a little bit so we can get it down here in the United States. If you notice, we're going to have the sun rising in the east, this is the east coast of the United States, and setting in the west because of the way that the Earth is rotating. Okay? So if you're looking down from above the North Pole, looking down at the North Pole, you notice that the Earth from that perspective is rotating counterclockwise. Okay? Alright, I'm now on page 227. What determines the length of a year? As Earth rotates on its axis, Earth is also revolving around the sun. And although you can't feel the Earth moving, it's actually traveling around the sun at an average speed of almost 30 kilometers per second. We don't feel that because we're completely accustomed to it. The motion of a body that travels around another body in space is called revolution. So we, on the Earth, are traveling around the sun, so we are revolving around the sun. Okay. The Earth completes one full revolution around the sun in 365 and a quarter days, which is what we call 1 year. So it takes a year to revolve around the sun. It takes a day to rotate on our axis. Okay? All right, continuing on page 227, I'm down at the bottom paragraph. Earth's orbit is not quite a perfect circle. It's actually an ellipse. An ellipse is sort of like an oval. Okay? It's pretty close to a circle, but it's not a perfect circle. In January, the Earth is about 2.5 million kilometers closer to the sun than it is in July. Okay? The big thing here is that this probably or hopefully tells you that the distance from the sun is not what determines our seasons. Because if you think about it, in January, we're actually having winter. And that's when the Earth is closer to the sun. It's still a long way from the Earth to the sun. We're 2.5 million kilometers closer than we are in July, but it's not a big enough difference to have much of any effect on our seasons. The big thing that affects seasons is the tilt of the Earth on its axis, and that's what we're going to talk about next. All right, so before we go on, let me show you the notes that I've taken and the highlights that I've made. All right, on page 226, the word axis I actually boxed, and then the definition I underlined. It's an imaginary straight line running from the North Pole through to the South Pole. I have underlined or highlighted the definition for rotation and the definition for day. I have added a definition for terminator. Terminator is the boundary line between daylight and darkness. Under the time it takes for Earth to rotate once, Earth rotates in a counterclockwise motion around its axis when viewed from above the North Pole. You do have to specify which pole you're talking about because it's different. Because of this, for us, the sun appears to rise in the east and set in the west. On page 227, the motion of a body that travels around another body in space is called revolution, so I highlighted that. Earth completes a full revolution around the sun in 365 and a quarter days, or about 1 year. And I also highlighted the sentence that says in January, Earth is about 2.5 million kilometers closer to the sun than it is in July. But then I made a note down there in purple and pink. The distance from the sun does not determine the seasons. That is really important for you to understand. It is the tilt of the Earth on its axis that we're going to talk about in a minute that is going to determine the seasons. Okay? Number 7, finally. Imagine that the Earth's current position is shown at point A, right here. Write the label B to show where the Earth's position 6 months from now is going to be. Well, 6 months from now, it's going to be halfway through its revolution around the sun, so we need the one directly opposite, so that one should be B.